Okay, welcome back, guys. So we have question from chapter 4, and we need to replace the loading acting on the beam by a single resultant force, and we need to specify where the force acts, and we need to find that distance from point A. So as always, we need one single force that is applying on this beam, and let's say the force is something like that for now. And we're gonna call that force Fr, and we also need to find the distance x from point A where this force is applying in order to have one single force or the force coupled system for this question. So before we start, please make sure to subscribe to the channel and let me know if you have any specific problem from the 3 textbooks that we are covering in this channel, and let's get started. So first of all, we need to find the sum of all forces, and let's call x and y in here. And let's start with the sum of all forces in x direction first. So we have the x component of the 450 Newton force, which will be this component, and this will be our y. And if you want to go with the x component, first of all, we know that the 450 Newton, the component is positive, and since we know this angle is 60 degrees, cosine of 60 will give us what we're looking for. The second force is only in y direction, so no x component. And the last one is the 700 Newton force, which this will be our x component. As we can see, it's in the negative direction, so minus 700. And for finding that, we know that's the sine of 30 degrees, which would give us this, or this angle is also 30 degrees. Sorry, this angle is also 30 degrees. And they would be all for x. And if we calculate this, we'll get minus 125 Newton. And the direction or negative sign shows that it's to the left. Let's move on to the y component. So we have the y component of 450 Newton force, and as we can see, it's negative 450 this time. The y component will be sine of 60 degrees. We had cosine for the x component, and we have the 300 Newton force, which is downward, so negative sign, and the last one is the 700 Newton force. Again, it's downward, and this time we will have cosine of 30. And if we calculate this, we'll get 1296 negative, which shows it's downward, and the unit is Newton. So we found the sum of all forces in x and y, and if we calculate the magnitude of F, we'll have what we found for x, which was minus 125 squared, plus what we found for y, and this would give us 1302 Newton, which will be the magnitude of Fr. So we know that our Fr would be something that has both negative x component and negative y component. So this will be our Fr. This will be the 1296 that we found for y, and it will be 125 for the x. And if we want to find this angle, let's call it theta. We'll see that the theta will be tangent reverse of y component, which is minus 1296 over minus 125, and this would give us 84.5 degrees. So now we know that the Fr that we have is actually not in this way. It will be something like that. Call it Fr, and I'm gonna clean up the previous one. And that would be the first part of the question. We need to find the single resultant force, and we found FR, we found both magnitude and the angle that it makes with our beam. And next part, we need to specify where the force is acting, and we need to specify the distance of the force from point A or the X that we are looking for in here. I'm just gonna clean up all this information. I'm just gonna put the single force that we found at the end of this process. So what we found at the end for FR was 1302 Newton, and we found the angle here will be 84.5 degrees. So that was the first part. And now we need to find the sum of all moments, as always, counterclockwise positive about point A. And we have to go with the moment of all the components that we have in the figure. And looking at point A, we'll see that none of the X component of the forces can make moment. So we basically go with the Y component of each of these forces. And as we can see, all of these forces about point A make a clockwise moment, which is negative. And what we have from the FR would be also, we have this as X component and this as Fy. So what we have for FR would be the Y component of FR, which we found 1296 times X. And as I said, since the moment is clockwise, we have a negative sign. And that's pretty much for the FR. And this has to be equal to the moment of each of these three forces about point A. So on the other side of the equation, we're going to go with the moment of each of these. So we have a negative sign for all of them since they're clockwise. And let's start with the 450 Newton force. By the way, for the moment, we are using the 2D shortcut that we have for finding the moment in 2D. I'm going to put the link in the description below. Feel free to check that one out. And basically what we need is the vertical force and the distance from the line of action of the force to the point that we're finding the moment about. So the Y component of 450, as we said in the previous section, will be 450 times sine of 60. And the distance here will be the distance from here to here, which is 2 meters. We have the same thing, the 300 Newton force, it's already only in Y direction. So we have the force plus the distance, which is from B to A. So it's 2 plus 4, or 6. And the last one is the Y component of 700 Newton force, which is 700 times cosine of 30 degrees. And the distance is 2 plus 4 plus 3. So we'll get 6 for this one, and 6 plus 3, 9. And we also have a moment at the other end of the beam, which is 1500. That moment is also clockwise, so we have a negative 1500 in here too. And that would be everything for this system. And from here we can calculate the X, since there is only one unknown in here. And if we do that, we'll get 7.36 meters. And that would be the final answer for this question. Again, please make sure to subscribe to the channel and share this content with your friend that might find this helpful. And you guys take care. I'll see you in the next one.